In this video, we're going to set up Python on Windows to be able to work with large language models locally. All of the links contained in this video are located in the comments area, so be sure to check that out. To start, we're going to download Miniconda. It's a lightweight version of Anaconda, and it includes Python and Conda, which allows us to control and set up our virtual environments easily. After the download completes, let's go ahead and run the installer. Select all of the default settings. Just hit next, 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 install, and it should go pretty quick. After it finishes, we'll uncheck these boxes. We don't really need to see that. Feel free to leave them checked if you want to read more about it. Now let's launch it. It should be contained in the Start menu, and we want to look for Anaconda prompt. When it loads, it will load the base virtual environment. We're going to create a new one. So we're going to create one called env310, and we're going to specify Python version 3.10. That's because a lot of the libraries we're going to use for the LLMs require this specific version. The install goes really quick. And when it's done, Python 3.10 will be installed in our virtual environment. So next we'll activate our new virtual environment using this command. You'll see the new virtual environment is activated because it shows up there on the command prompt. So okay. That's all we're going to do for now. Let's just exit and we'll install Microsoft Visual Studio Code. We'll go to the Visual Studio Code download site and we'll download the installer for Windows. This is a pretty small, lightweight installer as well too, so it should download fairly quickly. Then we're going to launch the installer. So again, we're going to keep all of the default settings and just hit next, 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 and let it install. Again, it should go pretty quickly. And here we're going to uncheck launch. So we're going to get used to launching VS Code from the Miniconda prompt. That way we can specify what virtual environment we want code to work in. So we'll open up the prompt, we'll activate our virtual environment, and simply type code. And it should launch. Okay, now we're going to install a couple of very useful extensions. So we'll click the extension icon on the left side, and right away you should see Python by Microsoft. We'll just click install, and it should go pretty quick. And the next one we want to install is just right below it. It's called Jupyter, also by Microsoft. And we'll just click install there as well too. Both installs should go pretty quickly. Next, we're going to go to settings, and we're going to configure two important settings. First, type shift in the search box, and then click on Jupyter in the list, and check the box for execution selection. This is a very useful setting that allows us to execute partial code rather than having to run the entire code. The other useful one is word wrap. So we'll look for notebook output word wrap and enable that checkbox. Now we're ready to create our first program. So we have to open a folder. Use the icon on the left to get to the file and folder settings, and you can close all the other windows and mark them done so they don't reappear. If you want to, that's your preference. Okay, well, open a folder. I like to keep all my programs organized under C in a folder called progs, and then create a subfolder for each of the different projects I want to work on. For this, we'll just call it project 1, and then we'll select that folder. And you gotta click the checkbox and trust that folder for execution. Then you can click the icon to create a new file, and all the files have to end with .py. Okay, we're going to write one line of code and we're just going to say print hello. And then we're going to highlight this code and hold down the Shift key and press enter. The first time you execute code, it might ask you to allow VS Code through the firewall. You can hit cancel. At the next prompt, we're asked to install the IPY kernel. Click install. You can use this icon on the left side to expand and close your file and folder window. This part can take a few minutes, so just be patient. When it finishes, we'll know that it's done because the output of our code will appear in the interactive window. And there it is. It says hello. You just created and executed your very first Python program. Nice work. Okay, now we're going to create our first program that works with a large language model locally. For this, you can go to the link in the comments area and copy and paste the code right into your script. We're going to highlight it and execute it. Okay, right away we get an error message saying that the transformer module is not found. So we need to go back to our Miniconda virtual environment and type the following. This will install the libraries we need. The main library we're installing right now is called Transformers. It was created by Hugging Face. With this library, we'll be able to access thousands of different AI models locally. Once it finishes installing, it will go back to our command prompt here at our virtual environment. Okay, let's go back to Visual Code and let's try to run this again. Highlight it, hold down Shift, press Enter, and this time it's going to run now that we have the Transformers library installed. When it runs for the first time, it's going to download the language model from the Hugging Face website. It's going to cache it on the computer and then we'll run it locally. For this, we're using the small LM2 series of language models. These models come in 3 different sizes. There's a 135 million parameter model, a 360 million parameter model, and also a 1.7 billion parameter model. For our first example, we're going to use the 135 million parameter size model because it's only 300 megabytes in size, so it doesn't take very much disk space. Alright, so it finished downloading it and executing, and here we have the output. For this example, we asked the model, what are LLMs? And it gave us a response. But as you can see, there's also quite a few different warning messages. So if we want some cleaner output, let's copy and paste this code. I've added a line for import logging and set the logging to show only error messages. So let's highlight the entire code and run it again. And this time we get a real clean output, only showing the input question and the model's output. If we take a look at the model's output, we can see that it's truncated. It's really short. We can make it longer by specifying a parameter called max new tokens. We're going to set it to 150 tokens. Now we can highlight just this portion of code, hold down the Shift key and press enter to execute just this code. That's the really nice feature about that Jupyter extension. And here we go, we get the output, and as you can see, it's much longer. So the output of these models are not going to be as coherent as the really large language models like ChatGPT or some of the other ones out there. The commercially available models generally are hundreds of billions of parameters and require many high-powered servers to be able to run. So for these models that we can run on our own computers, we're going to get different results, that's for sure. But let's see what happens if we use the largest of the small LM2 family model, the 1.7 billion parameter model. In this code, I included all the 3 different models, but I commented out the 2 smaller ones, leaving only the 1.7 billion parameter model. So we'll highlight the code and then execute just this portion, and it's going to take a while to run because it has to download the 1.7 billion parameter model first. This model is close to 4 gigabytes in size, so this will take a while and will use up quite a bit of disk space. When it finally finishes, we can take a look at the output and see how it compares to the other size models of the same family. It's pretty neat. This time, let's try the 360 million parameter model to see how it compares. To do that, we'll uncomment that line of code, highlight it, hold down the Shift key, and press Enter to execute just that line of code. And again, since this is the first time we're using this model, it's going to download it from the Hugging Face website and cache it to your computer to run it locally. Once the models are cached, it's important to know you can disconnect your internet connection and still run these models. The 360 million parameter model is about 700 megabytes in size, so be prepared to use up that much disk space. And so here we go. Now we have the output of the 360 million parameter model, so we can compare the outputs between all three. Here's a tip. Because we are running our code interactively and changing between different models, it's hard to tell sometimes what model are we actually using. To help with this dilemma, we can either close the interactive window or click Restart and just rerun our code so we know for sure, or we can use this highlighted code to print the configuration of the model. Let's try a different input prompt. So this model is good at text generation. So we're going to give it the beginning of a storyline and see how it finishes it. Okay, we'll highlight our code, hold Shift, hit Enter, and execute it. And there we go. This model gave us that output. We'll print the model config, and it shows that it's the 1.7 parameter model that we're using. Let's see how the smaller model finishes the story. So I hope I've given you enough information in this video for you to be able to start programming with Python on a Windows computer and work with large language models locally. If you like this video, be sure to subscribe to my channel. And also check out my articles. Links are in the comment area. I have a lot more videos to go through, so stay tuned, and thanks for watching.